and also he has guided 5 PhDs and many MTech students and 2 patents in his credits. So this is the summary. This is the summary of this resource person. And now I will hand over the session to Dr. PK Jain, sir. Sir, you can carry on, sir. You can share the
Yeah,
screen and
thank you.
start, sir.
Thank you very much for a nice
Thank you, sir.
introduction. Uh,
Thank you, sir.
and as now I'll share my presentation. Just a
Yes, sir.
minute. Huh?
Yes, sir.
Mm.
Yes, sir. Please, sir.
Just see, is it okay? Visible?
Yes, sir. Yes, sir.
Okay, that's good. That's
Yes, sir.
good.
Visible. Carry on, sir, please.
Yeah. Okay, so this can be removed. Uh, Wait a minute. No. This is going this side. Huh?
This one.
Why? Because इसमें आधा कट रहा है ना? नहीं, नहीं. Okay, right. So as in fact, always I have issues with the whenever it comes to a online presentation. Okay, thank you very much for all the participants, those who are participating. Actually, such type of lectures, I always consider those the lectures like an interaction. So anywhere in between, if you find any questions, any doubt, anything, you can interrupt me because purpose is just to get the transfer the information and knowledge. Okay, as it was told by Dr. Pawan that I'm from ARCI, which is an International Advanced Research Center. This center comes under Department of Science and Technology, and this is located in Hyderabad. So today I'm going to talk about the synthesis of carbon nanomaterials and their various applications. So actually this ARCI is a very small organization, not too big, but it is an autonomous center and we have a separate mandate. I'll just give you a brief of what ARCI does. Okay, and then we are around 80 scientists and 55 technical staff, 45 administrative staff, and we have a good number of students, around 120. And all the services like security, the electricity, and everything is outsourced. And our mandate is also very clear. We have to develop a high performance processes for the niche market. Like suppose we work on composite, so we don't work composite for helmet or civilian applications, just which is a common use. We work for a niche market, like for defense and ISRO or strategic sectors. And then we develop, once the technology is established, we demonstrate into a prototype scale, or you can say the pilot scale, and then ultimately we transfer the technology to the intended industries. The technique, or many times the industries comes to us for the technological solutions, and then we provide the solutions. And of course, we create, as I told you, 120 numbers and BTechs, MTechs projects also. So we do a lot of human resource development. So this is our center. Whenever you go, you come to Hyderabad, it is near to airport, a beautiful campus. We work on, as I told you, we work on various aspects like nanomaterials is one center. We have divided whole our center in ARCI into many small centers, like Center for Carbon Materials, Center for Nanomaterials, Center for Ceramic Processing, Non-Oxide Ceramics, Center for Laser Processing, Engineering Coating, Sol Gel Coating, Solar Materials, and of course, we have a very good Center for Characterization. We have two centers located in Chennai. They are Center for Fuel Cells and Center for Automotive Materials. They are in technology, IIT Technology Park. And very strong, we have a technology transfer center because many times what happens, the industry's language of understanding is different and the technical people we are having a different. So we have to bring them into one platform. That's why our technology transfer center helps us to have a common interaction in the when it comes to the technology transfer, because that includes like IP protections. Those, since you people are all are into that stage where intellectual property right also has to be protected, the commercial aspect also has to be protected, assessment of the market, assessment of everything, and what level of industries you are targeting. Suppose in your college or in your institute you are doing it in a test tube level research, but industry will not get excited because that TRL level, technology readiness level, is different. Okay, so these are the few technologies which we have transferred to various industries like electrospark coatings. If you just go ceramic honeycombs, heat pipe, evaporation boards, PM grade iron powder, all those things, many things are there. And these are the two list is continued, and these are the two technologies where I was the project lead. But these 20 numbers are we have transferred to many industries. I will just give you a glimpse of what type of activities we work so that you can appreciate. Like in a ceramic centers, we work on a transparent ceramic, like a ceramic which will be useful into all our defense application as a visor. Like in a helmet, if you see the glass, that is a visor because it has to withstand the bulletproof. And the cellular and porous ceramic and the pressure slip casting, we have different, like if you want to make a sphere out of ceramic or a extruded pipe or a honeycomb structure, all different type of structures are possible through all our techniques. As laser processing, we have all state-of-art laser like a femtosecond laser or all micro machining, carbon dioxide laser or a Nd:YAG laser. So if you can just see the corner one, if you see here, I'll just see the corner one. It is a different type of very specific component which cannot be managed made through a normal engineering processing except the laser processing because you are having a multiple channels. Those channels cannot be designed by normal machining. Like engineering coating, we have different coating facilities like thermal coatings like D-gun, which is used, and the electron beam EBPVD, beam processing, the laser, the MAO, micro arc oxidation, and chemical processes, all those things. When it comes to all our blades for engines, turbine engines, blades, we are the first choice for coating the turbine blade. We have a sol gel coating, which is like basically a chemical process based coating, where something like in a glass, if you give a coating, is scratch free. So glasses will become a scratch free, and many times like a colored glasses. Whenever you want to recycle the glasses, the colored glasses will become an issue, and the chromium is also used. So we use a normal sol gel coating where chromium is not there, and these type of coatings will be useful for recycling of glasses very effectively. Then we have a very good center on solar energy materials. That solar energy, we develop a lot of panels and the coatings onto the panel, solar cells like perovskite solar cell or CIEGS solar cell. Everything is there, and we have also developed an anti-reflection coating or even the self-cleaning coating onto the panels. So whenever there is a rain or dust or something is there, it will automatically self-clean, or it will require a very less efforts to clean it. Nanomaterials, as most of the institutes in India are working on nanomaterials, but still it is a quantity is a big challenge. People work in milligrams or grams. We works in kilograms. So our level is different because like for battery applications, the LFP or even the zinc baryster or even the nanofibers for the textile applications or everything. So we have a state-of-art facilities in our centers, and this technology also is transferred like a anti bacterial coating onto the cloth. So suppose you use this silver coating, nano silver coating on a cloth. So whenever it is dust will not adhere, and you don't require to even wash it. See, it can withstand for a longer period. Otherwise, in a normal tropical countries like in India, the washing of cloth, most of the good water is used in the washing of cloths, whereas many places you will not find water for drinking also. So this time, like this way, our institute can help to preserve the natural resources. This is a center for fuel cell. As I told you, it is in the Chennai. So like a fuel cell stack, They make it for hydrogen generation, the battery, supercapacitor, hydrogen storage. So this stack, they are using the bipolar plates. Earlier they were using the graphite. Now they are exploring even the steel plates also can be explored, and they have also transferred the technology for static application. This is a center which is working on automotive materials like for magnets and other things, rare earth, all those things. They work. They also have a full line of battery where they can make anode materials as well as cathode material, the full cell, and it is located in IIT Chennai. When it comes to nanotechnology, because nowadays people are talking about nanotechnology, now this is if you go back into the history, people always was the science is derived by the certain discoveries or invention. In early centuries, we were having a vacuum tube technology where in first half of the century, we have seen a lot of invention on television, radar, radios, all those things have come. And the second half of the last century was the semiconductor technology, where we have seen the cell phones, computers, transistors, and the internet. Now, this is the era after 2000. We are in the field of nanotechnology, where the robots are there. Of course, the bio is also a part of a nanotechnology, bio nanotechnology or anything. So everything is driven by the certain directions, and the whole world is now working on the nanotechnology. We are in this era. So exactly what is the nanotechnology? Because already people are knowing aware whether this is a new discovery or it is a old things, but we were not knowing whether it is a nanotechnology or it is a different. So historical use, if you just see, these are the Lagergus cup in the Europe. The cups are used, and if you put a
Sir,
light, hello,
PK Jain, sir. Sir, sorry for interruption, sir. Sir, can you use a presentation mode, sir? Full screen mode, sir.
it is not in the presentation mode? But from my side, it is on
Actually,
the, yeah, let me see.
inside one Microsoft 365 ad is showing, sir.
That is also coming. Yeah, that's what I'm also wondering.
Okay,
Wait a
maybe
minute,
that
just a
is
minute.
ad, sir. Okay, sir. Okay, sir.
Just a minute. I'll ask my daughter to help me. Yeah, okay,
Okay, okay, sir.
please.
Sure, sir.
That is what she told. It will not be there. I think, just a minute. You switch.
Okay, sir. Okay, sir.
Hello, sir. Hello,
Madam.
sir. I think sir is not.
No, no, actually,
Okay, okay.
I
Sir is
think
there,
in this,
madam.
but no,
Sir is
I'll tell
checking
you.
the
Sorry,
PPT.
sorry,
I'll tell you. No, no, sorry,
Yes,
sorry
sir.
for
Yes, sir.
that. In this
No
particular
sorry,
problem,
sir.
sir.
computer,
That
no,
screen was not.
I'll tell you the problem. What my daughter explained, in this computer,
Sir.
Microsoft Team is not there installed earlier.
Okay,
Oh,
So
okay,
this
sir.
ad will be a part of the presentation. We have to
Okay,
bear with
okay,
that.
sir.
Otherwise, I have to go
No
with the
problem,
other
sir.
computer. No, I have to go with the other computer where Microsoft, but it will take some time for that. So kindly
No
bear with that.
problem. Please continue, sir.
Yeah,
Yeah,
is that
continue, sir. Please continue.
yeah, yeah. Okay,
Okay, sir.
I know. You will see only the 20% you will not see, but you will enjoy in the rest of the 80%.
No problem, sir. Please continue, sir.
Okay,
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 sir.
okay,
Thank you,
okay.
sir.
Right. Okay,
Thank
okay. I think I'm sorry. Actually, I have used my this computer, which is not having a Microsoft, so that's the reason. Hmm. I was also surprised when my daughter. I thought it will not be visible to you. It is only visible to me. Okay. So this type of when the light was in the Liger's cup was put, there was a, but is it affecting the slide also?
Sir?
Hello?
Sir.
This is affecting the, because slide is also adjusted accordingly. Is it affecting it? Little bit.
It's visible, sir, but a little bit
No,
it
sir,
is
Little bit.
cutting, sir.
Okay, kindly bear
No
with
problem,
this.
sir.
Next time I will,
Visible,
no,
sir.
no,
No
I will
problem, sir.
use a computer which is having the MS team. Okay, so this MS team people have put one rider. Okay, so that they are forcing us to purchase the license. Okay, so
Yes.
if you
Okay,
just
sir.
see,
Please continue.
so if
Yes.
you just see this, when you transmit the light, the color of the cup will change. It means the gold particles are dispersed. Those gold particles or sizes are nano size. If you go to the Europe or many other countries, the painting used in the glasses are also having a lot of nanoparticle. And if you go to the Harappa and Mohenjo-daro's artifacts, even the ancient time also, you will find a lot of, if you go to the cross-sectional analysis, you will find a lot of nanoparticles. Apart from that, even in our historical use, in our katukas or kajal, whatever you say in your language, if you find out, there will be a lot of carbon nanotubes will be there, carbon particle, nanoparticles. And historically, when we were using this katuka or kajal or whatever you say, our ancestors were using it. Unknowingly, they were using carbon because they were knowing that this can protect the eyes. But now we understand the science is because they are having nanocarbon which can absorb the ultraviolet rays, and that's why it protects the eyes. Now science, we know earlier as a technological or as a uses, our society was using it, maybe knowingly or unknowingly, but now we have the tools to know what exactly inside the this powder. And of course, if you just go to any search engine, Google or anywhere, you will find the maximum number of hits into this. And this is the area which affects almost all segments of application, whether it is electronics or it is a space or it is bio or it is defense or it is sports or it is cosmetics. You will find nano everywhere. So that has become a very strong influence in the scientific line, which is affecting the applications in all areas. And of course, big money is there. Like a lot of funding agencies, they give a lot of money if you are working on nano. The reasons are also very clear, because in nano you are having a ability to change the material's properties drastically. Whereas in any other processes, whenever you are doing it, it is only incremental changes. Whereas once you convert many materials into nano and control the particle size, and as per your application, then the properties enhancement is very, very significant. And that's the reason the most of the countries are giving a lot of funding for the nano applications, nano based science and research. Now, who decides how to work in nano or all those things? What is the directions from whom? Of course, in India, we take directions from Google. But Google, those who are the developed nations, from where they are taking it? They are taking it from the nature. If you see the birds, they are the driving force of the all aerodynamics will be used in whenever the aircrafts are designed. So these aircrafts are designed whether it goes with the motivation is only the birds. When they fly from a few kilometers above in the sky, and then from there how to come down very fast with the less friction of the air. So this type of design will be helpful for the aerodynamics. When it comes to lotus leaf effect, the hydrophobic angle, all those things are there. All those things are possible. That's the reason we are trying to develop a hydrophobic coatings, because we understand what is the surface tension role. Now we understand, and that's the reason this nature lotus leaf effect this force us to go for, if we want to develop a hydrophobic coating, what should be the type of materials we have to select so that it can the contact angle we can control. Like if you go to the spider net, they are very, very strong if you just go to their specific strength. The spider nets can be protected. Okay, I'll hide this. Okay, and then you can control. It can be useful for many applications, highly protein. If you just see the mosquito, the mosquito is a very, very strong machine of nature. Nano machine, I'll rather say. It senses where the blood is there with its string, and then drill it from the same string, and then suck it as like a pump, and then carry almost 5 times, more than 5 times of its weight, and it becomes a flying machine. Such a nano machine is, if it we scientists can develop, that will be miracle. So these mosquitoes are one of the driving force for all mechanical or the nano engineers, those who wants to do a research into this. And many times, if you see how that development has happened in a Second World War, this man in the left hand side is holding a big camera just for the watchtower. He is sitting with the watchtower and 10 photos in every time, and then takes it. Now we have a drone which can go any places. In fact, drone applications have become so common in our functions also, like marriage function also, these drones are being used. So the science has gone from such a heavy to small size. If you just go to the war structure, this type of war, earlier the warrior used to use that the coat or whatever the guards, they were using the weight of those things were was almost more than 30 kgs, because it used to be a metallic one, like Rana Pratap or somebody, you whatever they have used. Now, if you just imagine a 30 kg a cover, you are holding it and then going for a war. Hmm. It becomes slightly very, very difficult for any warrior to wear it. Now we are having a 3 point or maximum around 3 kg bulletproof jacket. Even bullet will not pass it. So that's how the weight saving science has really gradually increased in such a way in last 5, 6 decades. Now this man has predicted the computer will be like this in 1954. He predicted that computer will be like in 2004, like this type of computer. But now we have a laptop, palm top, anything is there. So that type sometimes predictions goes very wrong, because science is now in a very dynamic mode. Many times our film industry is also giving you a lot of fantasies, like Superman movies. In 1950s, 60s, this 70s, the Superman movies were very popular. A man will wear a special dress and the bullet will not affect. Now what we are having a bulletproof jacket. So the fantasy once upon a time, a few decades back, was a fantasy. Now it is a reality. Now this reality, the scientists or engineers, they get motivation. In fact, if you see our ancestors' mythological books like Mahabharata or even Ramayana, we have seen the Hanuman, who can become a very small as per the time, as the need comes, or a too big and then time comes. So the nano or the bigger things, that was the mythological character, but the possibilities. Similarly, in our Telugu cinema or in any cinema, in Indian cinema, a person will wear a ring and will disappear. So now disappearing things is now a reality. Now we are having a stealth technology where if you give a coating onto your spacecraft, they are not visible to the radar. It means they are invisible to the radar. So invisibility, it is not simply because war is not happening front to front. It is happening from aircraft or missiles. If your aircraft and missiles are invisible, it means you are also invisible to the enemy. Now, this nano has gone into a day-to-day life. It has gone into the sporting goods and where the golf, tennis rackets, those who play badminton, they must be knowing what is this nano. Is a very big series of nano rackets, which is very, very expensive as compared to the earlier one. The paints and coating, computer chips, nano composite, plastics, sun creams, nano textures, wonders, cosmetics, and list goes on. This is only the glimpse of some things. Now, if you see in our household things, we are having like nano silver coated washing machines or the refrigerator or even the stoves which is having a coatings. Now a knife or a spatula, anything falls onto this stoves, nothing will happen. Now we are having a microwave, even for shoes. If you just keep it into a, here we are not too much bothered, but in European countries, the smell and other things are very, very, those who into a high-end lifestyle, even the shoe smells can be taken out very fast, like old socks or something. In cosmetics and dressings, we have now, if you just imagine a nanoparticles are dispersed into your cream, they will be more effective. Whether it is a zinc oxide or anything, they can clean it. But as you know, the ancestors wise, we were using it, all those things like our charcoal, they were all very good. But since the science was not known, we were not able to make it commercially. Now the Western world is using those science part and capturing the market. But slowly, slowly in India, we are redressing ourselves. And if you just see in the market, a lot of our old things are coming into a new packaging, whether it is the I don't know what it is called in your local language, the turmeric or even the multani mitti, which is used for the face pack, or even the curds based this thing, charcoal. A lot of face packs are made from the charcoal, which is also another name is activated carbon. Now, if you see air purifier in last 2 years, when we have seen the COVID, these sales of air purifier has become very, very exponentially high. These type of, we don't realize the this thing is, but like if you see the in Delhi, the AQI level is running more than 500. Now you requires in your home also a such type of purifier which can give you a clean air. So this type of things are there, which is used as a nanotechnology is used in this type. Now coming to the coatings, whether it is a your surgical tools or even your domestic kitchen tools, if it is coating is there. Now if you just can we imagine a surgical tools where the rust is there, so you give a coating which will be long lasting. The coating tools will be long lasting and it can be used without any problem. In tiles, like if it is a small houses, tiles coating is okay, but now they becomes very, very effective if it is a sky high rise buildings. How to give a, otherwise you cannot give a cannot do painting into a high rise. Suppose if you want to do a painting in a Burj Khalifa, it is not easy. Like in our one-story house or two-story house, three-story house, we can use the jhula or the hanging platform and then do it. But when it comes to 150 story building, so you require a outer casing of a material of a tiles, which is given such a coating. The self-cleaning coating will be there, and there comes all these thing hydrophobic applications. Now, UV protective textile as well as into the sun creams are there. So they are also using the zinc oxide, TiO2s, all those which absorb the ultraviolet radiations. One use in the fiber chemistry and the porosity, control porosity. Of course, these are the ideas. But when you work on that, that each slide, whatever I'm showing, is become like a thesis of individual. Like people are working very strongly onto the fiber chemistry, how it works completely. A packaging industries is a very fast upcoming industry, which is like I'm from Hyderabad, and people are liking the Hyderabad biryani. But if you want to transport or this biryani or send it to other places, your packaging has to be very, very effective. Many people from Hyderabad, they travel to USA, they carry the pickle and other things. It has to be packed very, very effectively so that it can preserve all the moisture, everything, and it can be useful for the longer period. Now, these type of dresses are common, but 3 years back they were very uncommon. So this type of, if you see the cartridges, is having a activated charcoal, which can control all the poisonous gases, and whatever gases you will get, it will be very purified gas. These things are our defense circles is making it in the eventuality of a chemical warfare. If chemical warfare, you might have heard also, whenever any war happens, people, in fact, Corona was also a type of chemical war. Which some of people says that China has used against the world, and it was very effective from Chinese point of view. But in such type of war, you require a special protection. Now into a biological, this thing is targeted drug delivery system. Suppose a person unfortunately suffers with a cancerous cell or something, and whenever he or she undertakes the treatment, so the very good this whenever you are applying any taking a delivery or chemotherapy or something, your good cells also get damaged. So what happens as a result, a body will swell, your hair will fall, and you becomes not a presentable position, and all those things are there. So to avoid that, so wait a minute. So all those things, a targeted drug delivery system is there. So which can be give it wherever you want. It will only just go to treat that cell. As I told you, when you work on to a nano cream, if you see on the right hand side a model which is having half coating and half not coating. Basically, the half coated one is a micron size particle, and the left hand side is a nano size particles are there. So when these particles are dispersed into a cream, then they will be effective and then heal the wounds or anything. They can reach to the skin very fast. As I told you, these are applications like a hydrophobic in a glasses or into your rackets or into your cloth. Like this model is showing a coffee or tea or even the wine will fall onto a cloth, it will not adhere. There is a self thing, it will not penetrate, it will not wet. So what you have to do, one has to do the control of the contact angle, that you have to play with the chemistry of the fabric as well as the molecule, whatever you are using it, and then you can control. Then there comes you have to give a coating onto that. And nowadays people are not making coating onto the fabric, but into the fiber itself. So whenever fabric is made, any type of fabric, the coated fabric is there. And the research is going on, it should last for long. Now what is happening when you give a coating, after a few hours, the coating goes out. So research is going on for a long lasting coating, so that as long as cloth is there, you can use the effectiveness of the coating. Now, when it comes to the nano, the important point is the surface area. Because if you are expecting in a surface area, so what happens, just to give this is the internet image, when you use this type of cube which is having a 1 centimeter square, so what happens, the surface area is 6 centimeters square. But when you break this cube into 8 pieces, and each pieces you break into 8 further 8, you repeat this into 24 times, the same one cube will give you that much powder where you can make it like a full football stadium. The whole ground can be covered with this one small cube. So that's how the surface area increases. Your quantity requirement becomes too low. You will be effectively, if you give a coatings onto that, so that will be very, very effective. It penetrates into a larger area. Now it comes to surface to volume ratio. What happens when you are using nanoparticle? Your surface to volume ratio also increases. So when it is a small particle, you can do it like here in one of the graph it is, or one of the photograph. If 10 micron particles are there, the surface area is 0.22. But when it comes to 50 nanometer, the surface area becomes 44. So which is almost like 200 times. So that's how it goes. And in day-to-day life also, we use such type of examples. Only thing is we don't realize it. Suppose you want to cool down your milk, which has become very hot. What we do, we pour from one container to other container. That is one way. And then second thing is we spread the whole milk into a bigger container, which is having a more diameter, so that it becomes cool. Or else third one, we are doing it. We are moving this container into a water containing this thing, so that the heat will dissipate fast. In all the examples, what we are doing, we are only just passing, we are increasing the surface volume. The volume is increased whenever you are pouring from one container to other container. There also, the more particle you want to bring it in onto the surface. When you are pouring into a bigger container, bigger pan, again you are bringing the more surface particle come onto the surface so that it can dissipate. Same way here. So when the part surface to volume ratio is a very, very important property. Those who are working on nano, they should understand this will lead to a very good. So now how to make this nanoparticle? There are only two approaches. One is top down, another is bottom up. So top down approach is when you start it from a bigger particle and go on crushing it once it becomes nano. Like in our simple, whenever we are making a powder of a turmeric or chili or anything, this top-down approach is being used. So, but we can't say our mother as a technologist, nanotechnologist, even though she makes a turmeric powder every day to day. Why? Because she cannot control the particle size distribution. She is making randomly. So the difference in technologist and the normal thing is, if you cannot control the properties. If you cannot control the properties, that is not good for the regular productions, because you cannot have a variation in your properties. So this particle size controls, if it is there, even your mother also can become a nanotechnologist if she can control the particle size. And that's how research in India people are doing it. Whenever they are taking a bigger scale of a ball mill or anything, go on crushing it with a proper ball to sample ratio, what type of ball has to be there, what type of sizes of the balls are required. And that's how they control the particle size, the morphology of the particle. Everything can be controlled if you control the parameters. Now, bottom up approach. Now, this is like you take any from like a chemical vapor deposition is a bottom up approach. You take any chemical, try to deposit its vapor, and it becomes like a bottom up. So there are only two techniques. All the techniques will fall either in these two. There is no other separate two groups other than these two. So when it comes to comparison, like in a ball mill, as I told you, you go on milling it, you will get it the fine powder. But the challenges are disadvantage. You cannot control the shape of the particles. You cannot control the morphology, the ball, and there is always chances that the impurities will also be transmit or transfer from balls or from the container to the particles. When it comes to bottom-up approach, this looks to be simple, but again, you require very toxic materials, you require very expensive solvent, do it, and then many times it leads to environmental issues. So depending on your application, one has to select either top-down approach or a bottom-up approach. Now, this is a very important slides. Why? Because this is the whole base of the whole nanotechnology. Why this nanotechnology is very, very important? Because nanoparticles, when they are in nano size, they exhibit a very different type of properties, whether it is electrical, magnetic, mechanical, optical, chemical. For example, when it is in nano, the gold is in nano size is not yellow. The melting point of iron will come down. The density of carbon is not 2.26. The density of carbon nanotubes is 1.4. So when your density, your physical properties, mechanical properties, electrical properties, everything is changed except the name. So it means you have an opportunity to redesign or redefine the materials. And that's why you are challenging the predictable properties. And that's why, as I told you in the beginning, the most of the research groups are working because there is an opportunity to change the control the properties and with either electrical, magnetic, mechanical, or anything. That's the reason research, a lot of research attention in nanotechnology is happening. Now I'll come to this, what exactly into carbon. When you take the nanostructure carbon, is it a new, as I told you, people were using this nanostructured carbon like in a a toothpaste powder, tooth powder, a charcoal, or even into a domestic. If you, I don't know whether how many people are from villages, but earlier the ashes were also used for the cleaning of utensils, or even the katukas. So these are the ancestral use of carbon, and as a used into source of energy over a period of time, it has now become a one of the advanced material into. mm. So now carbon, what it offers. Carbon is the only material which is very hard, hardest rather, the diamond, the softest like graphite. It is white. It is can be made into porous. It can be made into any 2D materials or a highly good semiconducting materials. Whatever you want, you have a control over that. Of course, we will not talk about those diamond and other things because that itself is a big subject. But it can be made into a foam. It can be made into a balls. It can be made into activated carbon. Whatever you want, you can do that. So all those possibilities, as I told you, the diamond or the graphite, one of the hardest material in nature is diamond. Is such a hard that all the hardness will be in reference to diamond. And all these things are because of the structural sp2, sp3 hybridization. We'll not talk about the graphite. We'll not talk about the diamond. We'll talk more into the graphite. What exactly graphite offers? Nature is very kind to graphite. It has given a very good natural. We have not done anything. It is a low density material. It is a highly chemically inert material. You take a graphite piece and just throw it into any acid, even including hydrofluoric acid, HF. Nothing will happen. Very highly thermal conducting, electrical conductivity. I will show you some of the example where these type of properties are used. The low coefficient of thermal expansion, if you just design any material and if it goes into the space, the thermal expansion is very, very critical. Those who are into designing part of a material, they can appreciate that thermal expansion is very, very important. Low coefficient of friction. If you just touch the graphite, you will feel that the black layer has come in your hand. So such a low means it is highly lubricity, and self lubricity is there, greasy feel, and it is biocompatible. Biocompatible in the sense it does not react with the blood cell. If you take a lot of applications once upon a time was developed using graphite, whether it is an artificial heart or even the bone plate, everything. But of course, above all, it is only material in the whole periodic table which can retain strength at high temperature. Now, this properties is useful in our aerospace or defense sectors. Apart from that, I will tell you where it can find new and new applications, like all our brake disc. Whenever any aircraft is there, the brake disc will be always a carbon. The rocket nozzle, the nose tip of a missile. Missile, when it re-enter into the space, it touches the temperature of 2500 degrees centigrade. There is no material which can withstand that temperature. So graphite is one of them. EMI shielding, those who knows the electromagnetic interference, the nuclear. In the first wall of the nuclear reactor is always a graphite. The engineering application, suppose you want to press any material at high temperature, say 2000 degrees centigrade. What type of dye material you will use it? Other than graphite, there is no other dye. The all building in a brick, if you just see into the high temperature furnaces, all those things are graphite. The chemical application, hydrogen storage, battery and fuel cell. All batteries are using the carbon as one of the electrode, or the modified carbon. Biomedical, artificial heart valves, of course, not too much popular now because of strength limitation. And new materials have come up, but again, a carbon-based material only. Adsorbent material, like our activated carbon. Whenever if you want to absorb every day, every servicing, the engineer comes in our AquaGuard and changes only the activated carbon. Other applications like the pencil, the heat insulator, conducting paste, sealing, everything is from the graphite. Now, as these are the pictorial these things. If you see the turbine blades, or even these are the dies, graphite die, or electrodes of a high metallurgical, high temperature metallurgical furnaces will be graphite. All paint industries are using, all our tire industries is using the carbon black. And you will be surprised that Birla Carbon is one of the biggest carbon black producer in the world. And the tennis racket, the golf stick, all are using carbon fiber. Even the cycle, everything, the high-end cycle, of course, it is very, very light. They are using all, most of the automotive industries. The bodies are also made from the carbon fiber composite. If you see the motors and other things, the electrical connector, they are all from the graphite, because they will transfer from the mechanical energy to electrical energy. And this all absorbent, when these are the down the line, you can see a highly porous graphite which will be used as a scrubber into a high-end industries. Suppose industry is using a lot of chemicals, if they want to dispose it into the drain, they have to use this carbon to completely absorb it. As I told you, a lot of face packs are being made from the carbon. The plates is used for a biological application. One person is using the very strong legs. In limbs also can be made. Even this, our ancestors were using the powder of charcoal for the paste, as well as for face pack. And this side, the left hand side, you see one rings are there. These are the for the plasters. Whenever you have a bone fracture or something, generally people forces themselves into a plaster. But for animal and other things, this type of was developed based on the carbon composite. And the animal can have a lot of spokes. The holes are there where the spokes will be put, and it will give a free movement to the animal. And just to add on here, when Dr. Kalam, you all might have heard the name, when Kalam was asked in one of the interview in USA, then what is the maximum cherishable moment for him? So he told one, when he was the project or the director of defense lab, the two components the lab has made. One was the nose tip of a missile, and this particular for the animal, the for or even for the polio people, this type of structure was made. So you can imagine that these were the, in spite of all his achievement, so he remembers the achievements or the component made from the carbon. Now comes to the nanotubes. Nanotubes are that by naturally it was discovered.
అవి తీసుకొని రేపు శుక్రవారం కదా.
Can I continue?
Yes, sir. Yes, sir. Please continue.
Okay. I think some people have unmuted. I request all people to mute. If any questions are there, at the end, we will take it up.
Dear participants, please mute your system. Okay, sir. Please continue, sir.
Yeah. So this is a nanotubes which is naturally made. We cannot take the graphite layer and make into nanotubes. So it is a naturally the process will design or make it into a nanotube structure, whether it is single wall or multi wall, and the way it folds by its own, it can be a armchair or zigzag. So all those things are there by nature, and and why nanotubes are so important, because it is having extraordinary properties. It is if you compare with the most popular materials like size or strength or resilience or conductivity, or the conductivity, if you say the copper wire burns at around 10 to the power 6 ampere, whereas this is 10 to the power 9. So like this, it is one of the most favored material as a reinforcement, but it has its own challenges. Those challenges we will discuss. Now, when it comes to like all our graphite applications, whatever was there, people are using nanotubes, whether it is on nanoparticles or graphene. Now, new graphene has come in all battery application, lithium ion batteries. the research is going only onto the how carbon can be exploited better way, whether it is a carbon can be coated onto the material for the very high end energy density or in the power density. Everything is happening just because to do a carbon properties to be exploited better way. As I told you, this was one of the once upon a time very popular subject of our hydrogen storage. So can carbon nanotube will be used for a hydrogen storage, because whenever you want to use the fuel cell, hydrogen is one of the challenge how to carry the hydrogen, and that has become a bottleneck of fuel cell applications. So fuel cells will be mostly it is being used only for the mainly for the stationary application. For the transportation, hydrogen is a big challenge, but of course research is going on. What type of materials which can store the hydrogen very effectively. Now, this is a general applications like a CNT as a for many applications people are exploring. This is another atomic probe, like in our AFM, atomic force microscopy, or even say, for example, FESEM. SEM was there. How this field emission effect has come? That is because of the probe. Now it is using, earlier people were using different type of tip. Now CNTs, carbon nanotubes are being used as a probe material. What is field emission also? I will show you one or two slides. Now this is a nano electronic tongue. Now earlier, whenever any beverages or any coffee or different type of teas or the alcohol or anything, so there used to be how you will decide the green label, red label, or black, yellow label tea, because what is the grade? How you will decide? Because from the each leaves, how you will do. So earlier people used to hire people of a different type of taste. They will classify teas or even the which whiskey or which beer is better. So now people are using a nano tongue, which is basically a carbon nanotubes are fitted in there. So they will decide the resistivity of the material, and then it will be used for the nano tongue application. Now in electronic industries, for as a carbon nanotube, as a work as a gate, or CNT as a gate or anything, because it is having a highest degree of conduction, so which is will be exploited. Now it is act as a actuators. You just give a signal, it will activate it, a single molecule. So of course it is a very high-end research. You requires a very controlled those things. It is not easy because single nanotube separating is a big challenge. As I told you, how this will become, we become invisible. Like, have you observed any time that why are always our fighter planes are black in color? Because they are given a coating of a graphite based paste, which becomes like a stealth application. There is a lab called in DRDO, in Defense Lab Jodhpur, which works only on stealth. So all our defense systems, they work which will be to make it invisible to the from the enemy. These are the few setups of what we have in our ARCI, arc discharge. Here we take the two graphite electrodes to make carbon nanotubes. So deposit will become into a in other electrode. You crush it, you will get the nanotubes. Of course, apart from along with nanotubes, you will get more other graphitic powder that has to be separated out or purified. We have a chemical vapor deposition setup where we pass the carbon containing source. It can be a through some reaction or through the gases, hydrocarbon gases, and deposit onto the substrate. We also have tried through arc under water, which can be give a lot of different type of sources, laser ablation of a graphite, and this is of course a fluidized bed reactor, which is from the source of carbon will be from the bottom, and they will be fluidized. Those who are mechanical engineers, they can understand, appreciate what is the fluidized concept here. And then once the nanotube is formed, it will collect it into a container. And this is the only technique which is used in the commercial when people want to make tons and tons of carbon nanotubes. The fluidized bed reactor or the CVD based fluidized bed reactor is the only things. You can see here These are the reactor which is using the fluidized bed concept. Now, once you are making it nanotubes, what research is possible? Now, research is possible. You can have a control onto the catalyst or onto the parameters. Then whether you want a tip growth or a root growth or a mixed growth. So all those things are depends on your parameter. Those who do research, they can understand and appreciate what type of parameter you have to control. So to get what you want. Now in CVD, there is a possibility you will get a pattern structure. Everything is there, but there are challenges and limitations. The quality of nanotube is not highly graphitized. So unless you use a very high secondary treatment or heat treatment or arc discharge or laser ablation, you cannot get a very ultra high quality of nanotubes. So depending on your application, one has to select what type of process he has to use it. Of course, it is very commonly used in the many institutes. Like this nanotubes, we have developed a process where aligned nanotubes and you can open them with the process, the one end can be opened up. So this will also find a lot of some applications. In arc discharge, whenever we make a lot of impurities are there. So one has to be purified by using the chemical, thermal and mechanical milling. And if it is not properly used, you will damage the nanotube, which one can see. And of course, the how to estimate the CNTs are there. The TGA is one of the good tools which will decide what type of nanotubes, because thermal stability of each carbon is different. The amorphous carbon, crystalline carbon, or nanotubes carbon, the thermal stability is different. If you can control the TGA, you can assess what type of carbon is there. And if you do all those things, ultimately you can get a very ultra pure carbon nanotubes. You can see that the lattice fringes of nanotubes are there. Now, once you make carbon nanotubes, they are still agglomerates. So what happens, these agglomerates are becoming a big challenge to have a dispersion. If it is not dispersed properly, you cannot use it for the real applications. So one has to make them disperse. How to disperse? Either by the particles, size of the particles to be controlled, or to give a surface treatment, or use some sort of a dispersing agent. We call it like a surfactant or anything, but these are all impurities. So one has to make a balance between the impurities, how much impurities they can afford in your applications, how much disperse. Otherwise, what will happen? It will get settled down very, very fast. So you require, like in oil industry, oil applications, if nanotubes you have dispersed and they have settled down, they will not be effective. They cannot, it becomes a time will come, it will choke the whole process. So one of our PhD students have developed a process where the nanotubes can be dispersed for months together. They will be stabilized, and it is, he has been awarded a PhD onto the, he has dispersed the carbon particles in the oil for the engine applications, automotive applications. Now, this also can useful for the sensor, for alcohol detector. It can be used by doping this thing. All those possibilities are there. We can disperse into a polyaniline or anything. You can make a composite basically for sensors. Now, carbon fiber. This is, as I told you in the beginning, the carbon is having a very, nature is very kind to carbon. It has given a very good properties. But the one important properties which nature has not given, it is very, very weak mechanically. You have seen also the graphite pencil. You cannot hold it, it will break very fast. So you require a structure where you have to improve the mechanical strength. How to improve the mechanical strength? You make a carbon fiber, disperse into carbon matrix. So you will make that as a carbon-carbon composite. Carbon fiber is reinforced in carbon matrix, then it is called carbon-carbon composite. And once it is converted into a composite, the mechanical strength will improve. So to get the best, the carbon is converted into fiber. Now, if you see here in this whole graph, the specific strength and specific modulus, the whole metals into the too low because metals are very heavy. Then the glasses, then the ceramic, and then of course the carbon. The ultra high modulus is the modulus is called a rigidity. Like whatever strength you are putting, the force you are applying, the less is the strain, and that is very important properties for the aerospace application. So these are the sources from where one can make the carbon fiber, polyacrylonitrile or the pitch based or the vapor grown or the rayon based. Of course, you can see the in the top corner one photograph, the representation is from the human hair, the ratio, because human hair is around 150 micron, whereas carbon fiber is hardly 6 to 8 micron. How carbon fiber is produced? This is produced from the polyacrylonitrile fiber. Whatever sweater we are using it, they are also pen. But when you make a high molecular pen, that will be useful for the making carbon fiber. Of course, that is a big science. In India, still we could not able to make a good carbon fiber as on after many years of struggle. So ARCI is making an attempt, just to share with you, to make a carbon fiber plant in India. First time, because some of the efforts were there, but somehow we could not get to. Of course, Reliance and other private players are also doing it. So we are doing it with the help of Russians. So this is a whole setup. Now, how this has to be stretched, it has to be carbonized, graphitized, or another route is like a pitch, the base material of a petroleum is converted, it is used as a electrospinning fiber, and this fiber is converted again into a carbon fiber. And how it looks carbon fiber, this is the photograph, you can see commercially this is fiber is available in this form, 95% carbon. Now the strength is coming from carbon fiber. So carbon fiber either unidirectional or bidirectional or tridirectional or radial or anything multidirectional. All these things, depending on your application, one can use a carbon fiber for making the expecting to get the best mechanical strength. Now it comes to like your aerospace, which requires a very high modulus fiber, and whereas the cycle or your windmill, they require, or tennis racket, they require very low but high strength fiber. The cost is very difference when it comes to high modulus fiber or a low modulus fiber. Say low modulus fiber or high strength fiber costing around 4,000 to 5,000 rupees a kilogram, whereas high modulus fiber will come around 25,000 to 30,000 rupees a kilogram. Now, this is the process how to make a carbon-carbon composite. One has to make a preform and densify it, and finally you convert into a high temperature treatment, more than 2000 degrees centigrade, then it will convert into a particular carbon-carbon composite. Now, this carbon-carbon composite is for the all our aerospace. You don't go into that details. Like all our, this is the one of the cone structure you are seeing. This is the nose tip for a missile. This is the bottom. You can see a model of a missile, which is our defense missile. Whenever a missile goes into space, when it is coming back, it faces a temperature of 2500 degrees centigrade. There is no other material other than the carbon. These are the brake pad system assembly. You can just imagine a weight of a aircraft is around 500 tons, and the speed in runway is around 700 to 800 kilometer. If you convert that half mv square, mass you know, velocity you know, the energy generated will be only taken by the carbon. There I told you the high thermal conductivity of fiber helps to dissipate the heat very fast. And that's why these carbon-carbon composites are inevitable, or in all aerospace applications, this is one of the best material. Nowadays, composite, carbon fiber based composite, you know, those who are from Bangalore, NAL, HAL, they use carbon fiber very vigorously, but of course they import it. So almost 40 to 50% of aerospace applications uses the fiber composite. Now, as I told you, this nanotubes, whenever you want to make a composite, it has to be dispersed effectively. So if 0.1% CNTs were dispersed into epoxy, and this dispersion is very important. the difference between dispersion and distribution, those who are in R&D, they should understand dispersion has to be continuous. Otherwise, in isolation, you cannot really exploit the properties very effectively. If you want to get the properties of nanoparticles, it has to be dispersed rather than distributed. This is, as I told you, field emission. Carbon nanotubes are one of the best field emitter because they are very diameter is in nanometer. So they can emit. There's a reason they are large aspect ratio because diameter is too small and length is in microns and diameter is in nanometer. So almost like aspect ratio is more than 1000. Atomically short tip, you cannot convert any materials unless it is naturally made. And there's a reason. If you see earlier, the television was used to be on the back side, CRT, cathode ray tube was used. Now we use a TV, which is like a laptop, which is having a very thin, because emitters are different. So that's the reason now research is going on. In a flexible substrate, if carbon coating is done, the flexible TV can be made. This is a flexible graphite where the graphite flakes were treated with some chemicals and then it converted into a mechanical worms. Worms will be compacted and you will get a flexible graphite. This graphite, flexible graphite is used for different product development like gasket. Looks to be very simple, but it is a highly engineering product. You cannot touch the engine or even the silencer after running a 1 hour. So you require a material which should be compressible, which should give that withstand very high temperature, which could give you sealing. So this graphite, this is one of the material which is used for the wheel and axle plant in railways. Bipolar plates, many other things are there. Like this is a test, as I told you, whenever we develop, we go for a field trial test, then only we transfer to the technology industry. This is the wheel and axle plant, which is using when this photograph you are seeing, the schematic, the molten metal, it comes into a mold, and during mold, when it is coming, the gap, it will give a slippage of the earlier people were using asbestos, but asbestos is a carcinogenic. So a request has come. We have developed a graphite seals for them, and this is being used. As I told you, this is another applications where the contacts for evaporation board from a flexible graphite. Now, what happens? This evaporation board you are seeing on the top is they are both of a ceramic material. Whenever aluminum, they become like a heater. So whenever aluminum wire is placed on that, aluminum will evaporate and deposit onto your film, plastic film. And that's the reason all your uncle chips or your all food grade packets are having a silver lining inside, because plastic is not a food grade. To make it food grade, it has to be given a aluminum lining. That's whether it is a gutka or it is a haldiram or it is a uncle chips or anything, will be a silver foil is used. Earlier people were using the silver foil and taking this plastic and continuously rolling it, but the silver foil cannot be made less than 70 to 80 microns. Now this here, by evaporation technique, deposition technique, you can make it around 4 to 5 micron and with the same effectiveness. That's why you can save almost like a 20 times of your material, and of course very uniform. This is a fuel cell. The bipolar plate is made from the graphite. This is also passed, and one side hydrogen will flow, other side oxygen will flow. So it will act as a both both electrode. That's why it is called bipolar. So the same plate will be used one as a anode as well as cathode. And this is the assembly where the hydrogen will be passed, oxygen of course will be taken from the atmosphere, and you will get the power source. Another application of this carbon is highly porous. So what happens, this was used for the oil spill, to absorb the oil. So what happens, this oil, whenever oil spills are there, so this, if you spread, this is a highly porous carbon. So once you spill it, this, because of this porous structure, the oil will go inside through a capillary action, and you can recover back the oil by centrifuge or by squeezing or anything. you can do that. So around 78 to 80 ml per gram, which is very, very high as compared to any other material. Like people have used earlier, the polycarbonate, the cotton fiber, the milk beads, anything. So this exfoliated graphite gives the very highest degree of absorption. And we have a patent on that also. Graphene, as I told you, this graphene is another wonder material, which is giving extraordinary properties. How graphene is synthesized? You take the graphite flakes, intercalate it, exfoliate it, and then make it a separate plate, and then you will get a single layer of graphene. And this single layer is not that easy, but when you do experiment, you will get a multi-layer or a few layer, depending on your process. As I told you, this has to be estimated by a Raman or by a suitable technique, whether you got how many layers. So a process we have developed where we can develop a 3 layers, 7 layers, and 16 layers and 29 layers, depending on your centrifuge technique. These are the different techniques which is used for making graphene. You can control by the chemistry and make this graphene or few layer graphene or standing paper as a hydrophobic to hydrophilic, or vice versa, hydrophilic to hydrophobic by playing with the chemistry of the surface. These are the another we are making it into a different type of techniques. As I told you, these are the graphite powder. We are also making an electrode material from this graphite powder. This is a nickel-rich carbon spheres, which is used for in a batteries application or supercap. Whenever we make carbon powder from arc underwater, we get a different type of morphology, and this morphology offers a very good electrochemical properties. So we use our scholars, they make different type of applications. We are also working on a lithium-ion batteries. A small cap is made. We also work on recycling of tire tubes, which is being used heavily and discarded. So this tire tube, the carbon derived from that is also one of the interest. This is a battery setup what we have for a coin cell. One of our scholar works on to the using this few layer graphene into dispersing into oil, and then the lubricity of oil can be improved. Generally, the normal engine oil, around 14 components are added into a base oil to get the desired property for engine oil. But if you use graphene, out of 14, only few are required. All rest of the properties can be compensated or can be controlled by graphene. This technology was transferred long back, and now industry is working on it. As I told you, this is a very important slide. Those who are a young researcher, they should understand. I'm just within a few minutes, I will close it. This is a technique because one has to understand what is TRL level. If you are having an idea and doing experiment in your lab, you are still in research mode. But when you develop a component or something, it goes into the field trial, some testing is there, some prototype is made, that is called development. Once it goes into the industries, and industries are making it, producing it, it is called deployment. So one has to understand how to take forward your research to development to deployment. And that's the reason Government of India is making an attempt to give a funding to startup. Those who wants to do any startup, they have to write a good proposal and submit to the ministries. They will give a funding, but your project proposal should have enough strength to qualify to get the funding, and you should know what is the roadmap. Since you alone people cannot do, this is the era of collaboration. You should collaborate with your fellows, those who whatever you are not able to do, others, those who are doing it, collaborate with them, then you will get the whatever you want. These are the different description. What is TRL level 1 and 2 when you demonstrate? Okay. So as I told you, everyone is in comfort zone. Coming out from comfort zone is not easy. people have fear and other things, but once you come out from the comfort zone, it becomes like a learning zone. And once you learn it, you will become a master, and then the real growth will start. And life begins when end of the comfort zone. Okay. So one has to be very, very clear. Like I always give this type of examples to just to motivate people. There is a two things are there. Your research should not become opposite to the mainstream. In the center one, a person is running very fast, but not into the mainstream. So if you have to align with the what others are doing, you have to understand because reaching a goal is very, very important. One in the train, many people are standing. So just like that, we follow the Google, you will become one among the many, because Google will, you are not the only one who is following the Google. So Google already people are, somebody might have done, uploaded, and you become the follower. Maybe in the umbrella person, if you see, people may laugh initially, but at the end you will fetch it if your idea is innovative. And many times we have a feeling we cannot do. The horse is tied with the chair. Many times we have a feeling that we cannot do. It is your internal strength which will give you enough. If you feel that you cannot do, you cannot do. If you feel you can do, I think you can do. So most of the people are having solution within. That the person who is just looking at the other side of the wall is, all ladders are there, but still he is looking for a help from outside. So all solutions are lies with you, and this is the importance of a small step. Many people feels till big things will come, then only I will start. No, whatever small contribution you can do, one should do. And that's why having, if you are not upgrading yourself, once upon a time a premium car, Fiat, is now being used like this. So one should use, if you are premium or premier, you should continue to be premier, otherwise you will be outdated very fast. This man is having a lot of ideas, but not of tires, but the real tire what is required is not there. So if many ideas is no meaning unless that idea will not give you a solution, is no meaning of having ideas. In India, we are full of ideas. All people, if you ask one question, 100 ideas will come, but those ideas, whether it is workable or not workable, you have to assess, then only you can lead the real solution. Thank you very much for your attention. If anything is there, I'm open for the any discussion or any questions.
Thank you very much, sir, for your wonderful presentation, sir. Dear participants, now it's time for queries. You can ask questions, please. Dear participants, you can ask questions, please.
There could be two reasons when people don't ask
Sir,
questions. No,
sir,
no.
Jain,
Either
sir.
they have understood, or maybe sometimes shyness. Don't feel. No
Sir,
question is a wrong question. You just,
sir,
if
in
any doubt
chat
is there.
box, in chat box,
Oh,
there are
there.
some queries, sir.
Queries. Okay, let me check it out.
Shall I read out to you, sir?
No, let me check it out. Chat box. Yeah, I can see
Okay,
something. Okay.
from Guru Prasad, sir.
Yeah, you just ask.
Nano,
You tell, because I cannot read. It's too small. You just tell what is the queries.
sir, first question is, sir, are nanocarbon materials safe for the environment? That is the first query, sir.
Yeah, as long as they are pure carbon, there is no problem. But if they are having other things, impurities or anything, then there is a possibility those impurities can lead to some effect into environment. Like whenever in our pollution, what it comes out, it is a carbon particles, but they are impure carbon, unburnt carbon. Okay, those unburnt carbon, like if you see the fuel to air ratio, if you change it, your in your silencer, a lot of carbon will deposit. These are unburnt carbon. They are not the full pure carbon, but they are definitely, there is a problem in the environment, but the solution also will come from the carbon only. The only thing is you have to select the proper process, how to process those carbon.
Sir, another question is, sir, How does a nano electronic tongue work like a human tongue? That is the
Oh,
question, sir.
okay. Yeah. What happens once you have designed a particular flavor, each flavor will have some conductivity, resistivity. So what happens, they design this particular brand will have that type of uniformity. Okay. So they will design that, but any resistivity of that particular order, 10 to the minus this resistivity is there, that all your beverages will fall into that category. It will act as like a tongue. But of course, no materials in nature can replace the human being. Be clear. The tongue or eyes, whatever we see, no camera can see whatever we see. Okay. So that's a human complete replacement is not there. Only thing is based on your applications. You are only giving a signal that particular resistivity we require, and that's how you are branding it.
Sir, another question is, sir,
Hmm?
I want to know how particles are converted into thread like spins. What type
Mhm.
of actual process or additives are involved to it to a thread like structure? That is the question, sir.
Okay. Now, what happens, like if you have seen the cotton, hmm, when you are spinning, it becomes like a thread. The cotton is only a small microfibrils. Okay. These fibrils will interlock with each other, and that's how our cotton in our AP, we have a lot of cottons. They spin it and convert into a long fiber, kilometer long. Now, when it comes to particle will not entangle. You require a binder. Now, when you use some polymer, these polymers will be take this powder and convert them into a fiber form. Then slowly you remove this powder, this polymer, and this powder will interlock with each other. But directly powder will not convert into fiber. Or else, unless a binder like a coal tar pitch, which is having a self-binding properties, those properties can be electrospin. Is that clear or?
Sir. Yes, sir.
Yeah.
Yes, sir. Sir,
Mm.
another question, sir, from
Mm.
one person, Ashish Mishra. He's
Mhm.
working on carbon nanotubes for heat transfer,
Mhm.
and he is
Mhm.
asking that, can you please share some more insight on how the stability of carbon nanotubes were improved up to a month in the research work you mentioned? That is the question, sir.
Okay. So what happened? Which medium it is being dispersed, whether it is oil or water, hmm, or any solvent or anything. The chemistry of that medium is also very important. Okay. Now, why particles get agglomerated? They are having a charge on it. Okay. Each particle is having a charge, and these charge can be measured by a zeta potential. Okay. Now, if you can control those charge, you can disperse very effectively. How to control that charge? Either by size or by using dispersing agent. Now, dispersing agent, generally it is a surfactant, SDS or anything. You use it in a small quantity and control that this surfactant will go in between the two particles, and they will not allow this particle to become agglomerate. And once these particles are too small, too fine, they are nano size, they will stable. Once they will agglomerate, they will become micron size, they will become heavy, and they will settle down. Is that clear?
Yes, sir. Yes, sir.
Hmm.
Yes, sir.
Yeah.
Sir,
Okay. Next.
one more question, sir,
Hmm.
from Ansuya ma'am. And she is from civil engineering background, sir. And
Oh,
she is asking that how does nanocarbon interact with moisture and temperature variations, as this can improve the strength of cementitious material? That is the
oh,
question,
very
sir.
good. I should must appreciate this question because this research we have not included. We are also working using carbon nanotubes and graphene into a cement. Okay. Hmm. And try to improve. What happens this when you make cement, generally it takes days to cure it to get the maximum strength of 53 MP or whatever. Okay, in a cast. Now, when you use carbon particles, they absorb the moisture very fast, and then they do your sintering process, they control. And what is happening in turns, the concrete will be become stable within a within maybe very 1/5 of times. Okay, 2 to 3 days. And we are collaborating
Yes.
in this work with IIT Hyderabad. But this is a good question. I must appreciate
Yes, sir.
from you.
Yes.
Hmm.
Thank you, sir. Sir, another question, sir, in chat box.
Hmm.
If a carbon is blinded, it is if a carbon is binded with the help of polymer, please share your
Mhm.
opinion on its biodegradability.
Okay. Biodegradability, whenever you are adding carbon in a polymer, it is not biodegradable. Okay. Because polymer will the major player there. The carbon is hardly as a few as a filler. Polymer depends on your polymer. If your polymer is a carbon containing yield carbon containing polymer like phenolic resin, which gives you a yield of 60 more than 60%. But epoxy cannot give more than 10%. So epoxy cannot be a biodegradable. Okay. And what is biodegradable? Which does not leave any environmental issues. Okay. But it is depends on the polymer, which polymer you are selecting it and where you are dispersing your carbon. Carbon role is here very low. The polymer role is very high, more dominating. Okay.
Yes, sir. Yes, sir. Sir,
Mm.
one more question, sir.
Mhm.
Can we use nano carbon materials for bone grafting as they are used for human to replace?
Gathering as a can we use nanocarbon materials for bone grafting? Okay.
Yes, sir.
Now,
Yes.
what is mean by see, one thing is there. This is a tissue culture, and other things research is going on. But whatever nature bone grafting is there, still not many materials are direct replaceable, because nature, like if a bone breaks, nature will heals by itself. But of course, carbon helps in healing. But I'm not very sure about that, whether it will be really helpful for the bone grafting, because that is little away a biological question. But I will take a note of this, and if I get answer, I will give it to the organizers. They will pass on to you.
Sure, sir. Sure, sir.
Because bone
Sir,
grafting, I don't want to comment
yes,
just
sir.
because bone grafting itself is a big subject.
Yes, sir. Yes.
Yeah. In
Sir,
fact, CCMB, there is a
no.
one lab, one CCMB, cellular and cell microbiology. They work on this
Yes.
only, bone grafting. Hmm.
Yes, sir. Yes. Sir, one more question, sir. Can biopolymers be used with carbon?
Of course, of course. There's no. In fact,
Yes,
JNTU, one or two MTech
sir.
students, they used using our carbon materials for bio this thing, and that is possible.
Okay.
Then nothing. See, carbon is a material which is like a your that card which can be used anywhere. Now people are using in agriculture also, in a nano fertilizer.
Yes, sir. Yes. Sir, one more question, sir. How do boundary conditions and loading rates affect nano carbon composite behavior?
Boundary conditions. I'm again,
Yes,
you little
and
bit
loading
explain.
rates. How do
Actually, loading
boundary
is a no, no,
conditions?
no.
Yes,
Actually, what happens?
yes,
You, when you want to load it, generally, how you look at it, loading cannot be more in a major percentage. You want to use disperse only few less than 1%, 2% like this. Okay. When you add more, because of high surface area, they become like a more agglomerate. So many times properties will deteriorate rather than improving. Okay. So you have to be very, very cautious how to disperse it, very low percentage. And that is the balance. You have to make a balance that it should be sufficient enough to transfer the properties, but at the same time, it should not deteriorate the properties. That is a hit and trial method. You have to optimize
yes,
what properties you are looking for, whether it is a mechanical or thermal or functional, you have to do hit and trials.
Okay, sir. Sir, one more question actually from my side, sir. Sir, you
I
said
think you
that
should
this.
make this as a last question. Okay. Okay.
Sure.
Yeah. Tell
Sir,
me.
you said that these nanocarbons are used in implants, no, sir, surgical implants like that.
No, 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 no.
Can
I am
we
not
use this
surgical
for
implants.
implants? Yes, sir. For surgical implants, can we use this nanoparticles, sir?
Actually, graphene is used in dental.
Sir,
Okay. What
okay,
happens,
okay.
graphene? So whenever any bad smell or something is there, so in a suture and other places, graphene is being used. We have given graphene materials to our one of the hospital. Okay.
Yes,
So,
sir.
but I'm not sure about whether it can be used as a implant or some directly.
Okay, okay, sir. Okay, okay, sir.
Okay, thank you very much for your
Okay,
kind
thank
attention.
you,
Anything
sir.
is there, you can contact
And
Mr. Pon. He can convey to me
sure,
my
sure, sir.
and those who are working in carbon. Just I'll tell you, we are organizing a big conference on carbon materials in from 18 to 18, 19, 20
Okay, sir.
in BITS Plani Hyderabad campus. The
Okay, sir.
conference will be attended by more than 600 delegates all over India, where 10 international speakers are coming. And Kishan Reddy, our minister, is inaugurating.
Yes.
Dr. VK Saraswat, Niti Ayog member, and Samir Kamath and Ashutosh Sharma, they are the guest of honor. And many panel discussions will be there. If you want, I can share the brochure to Mr.
Sure,
Dr.
sir.
Pawan, and he can share it to in your group. Those who are
Okay,
interested
sir.
to participate, they can register and participate in that.
Sure, sir. Sure, sir. Thank you very much,
Okay.
sir.
Yeah.
Sir,
Okay.
thank you very much,
Yeah.
sir, for your valuable session, sir.
Thank
Sir, your
you. It's my
presentation was
pleasure.
very
Yeah.
informative, sir, and very clear and engaging, sir. We truly appreciate your valuable time, sir, and effort
Thanks a
that you
lot.
have
Thanks a
taken
lot.
today.
In fact, there
Thank you
was
very
some
much, sir.
technical glitch, but
No problem, sir.
thank you.
Thank you very much, sir.
Okay.
Thank you, sir. Thank
Right.
you very
Thank
much.
you.
Okay,
I'm
sir. Okay,
leaving
sir.
that. Okay.
Yes, sir. Sure, sir. Thank you, sir. Okay, dear participants, the next session is by distinguished resource person, Dr. Simhachalam Juttu. And first of all, I will introduce the next resource person. It's my great privilege to introduce our next distinguished resource person, Dr. Simhachalam Juttu, who is currently serving as General Manager at the Automotive Research Association of India, ARAI. ARAI is one of the India's premier automotive research and certification organizations, playing a vital role in vehicle testing, certification, research, and development for the Indian automotive industry. And coming to this resource person, Dr. Simhachalam Juttu. He had completed his BTech in mechanical engineering and further pursued his MTech and PhD from IIT Delhi. Over his professional career, he has contributed extensively to research and innovation, publishing numerous technical papers in national and international forums. His current research focus includes fuel efficiency enhancement and advanced engine technologies for sustainable mobility. Dr. Simhachalam Juttu, with him more than 2 decades of rich experience in the field of internal combustion engines, automotive research, and advanced simulation technologies. And at ARAI, he has worked on a wide spectrum of engine platforms, ranging from single-cylinder engines to multi-cylinder engines used in three-wheelers, passenger cars, SUVs, commercial vehicles, tractors, defense application, and generator sets. He has been instrumental in establishing simulation-based approaches for engine development, including advanced work in CNG and hydrogen engine technologies. vehicle and engine calibration, and fuel efficiency improvement programs. Dr. Simhachalam Juttu also played a key role in developing innovative methodologies for duty cycle-based fuel consumption estimation, vehicle field data analysis, and optimization using simulation tools, including the applications related to electric vehicles. His expertise also extends to automotive regulatory and type approval procedures, contributing to compliance with national legislative requirements. With his vast industrial experience, strong research background, and contributions to automotive methodology development, Dr. Simhachalam Juttu is an eminent expert and an inspiring leader in the automotive engineering domain. Let us extend a warm welcome to Dr. Simhachalam Juttu, sir.
Yeah, very good evening to all the respected professors, because most of the professors I can see over here, and also other faculty members. So I think today I'm mostly interested on giving the today's scenario on fuel efficiency and its importance and why we should study this particular activity. I will give you very brief on that, and also a couple of new concepts which we study from the fuel efficiency improvement point of view also I will try to touch. And if you have any questions in between, please you can interrupt me in between, or you can ask the questions at the end of the session. So I have a couple of presentations. Maybe I will take you through one by one. Are you able to? Hope you should be able to see now.
Yes, sir. Yes, sir.
Okay. Actually, why this topic is important? You might be aware about the current technology trends towards the EV, H2Is, fuel cell electric vehicles. These are the trend. This is the these are the current trends in the automotive sector, and also maybe in the mechanical division. Today there is no difference between the what is mechanical, what is electronics, electrical. So we are all working like a mechatronics. When we are working like a mechatronics, what we are neglecting is that fuel efficiency. So you might be aware that in 2016 there was a Paris Agreement where 194 plus countries have been signed to reduce the CO2 emissions. So whatever we are discussing about EV, fuel cell, hydrogen, the initiative behind all these things mainly the CO2 emissions. But really these vehicles are good in CO2 or bad. So I don't know how many of you are aware. The fact is that in today, all the vehicles, all the EV, either you take EV or diesel, gasoline, fuel cell, H2Is. So depending on the source of the energy, what we are getting, that will decide that the vehicle or the technology what we have developed is CO2 neutral or not. Current situation in India, we are depending on the coal electricity. That is about 75%. So 75% coal and 25% of renewable energy when we are using, then the overall CO2 impact on climate change is more or less equal to the conventional fueled vehicles, right? So because of this, we have a set fuel neutral or net zero emissions target by 2070 we have to see the alternative options so that we can reduce the carbon footprint. One of the option in that is improving the fuel efficiency. That is immediate solution to us. When we improve the fuel efficiency at engine level or at vehicle level. Sorry. Just 1 moment. Okay, engine level or vehicle level. So now coming to the next emission levels or next regulatory requirements like BS7. So BS7 is demanding the efficiency improvement at vehicle level, not at component level or not at engine level. So the demand is changing because of the technology limitations, because of the energy sources from where we are getting. In that case, the focus is shifting from the component level like engine, battery or whatever it may be to vehicle level. The energy what X I am giving as an input to the system, how much that energy is converting into the useful work. Any idea? Do you have any idea that either you take conventional fuel vehicles or EV, what is the total tank to wheel efficiency or well to wheel efficiency? Any idea? It is hardly 15 to 20%. Even if it is less than that for the commercial vehicles. And commercial vehicles are polluting 66% approximately. So the focus now shifting to the fuel efficiency improvement and go to the advanced technologies like EV, fuel cell EV, and H2ICE. So now today my focus is here on real drive fuel efficiency and energy audit. First, we should know how much energy is flowing and where it is going. What is the potential area so that we can improve this? Based on this only, we are working on this. The difference between the real drive fuel consumption and engine level VSFC, you can see here. This is the real drive fuel consumption and engine level VSFC. There is a huge difference. If you can see a simple logic, if you can apply to anywhere, I can achieve the best fuel efficiency at engine level or the best efficiency at battery level, battery conversion or motor conversion or DC to DC conversion. But when it goes to the wheel, that is the efficiency actually we are going to use it for the drive. That efficiency should be improved. So that's the main agenda what global innovators, you can say, or global technology leaders or policy makers focus. So now the shift is from the component level to real drive fuel consumption. So engine BSFC will never reflect what is there on the road. And on-road fuel efficiency measurement is not a direct representative of real-world fuel consumption at all. Any improvement on real drive, really it will reflect on direct fuel savings or CO2 reductions. You can other emissions also. Even not only in engine level, even it is applicable to the EV also. It is applicable to the fuel cell EV. You might be aware that when it comes to the hydrogen, there are different hydrogen types. What are the difference? Gray hydrogen, blue hydrogen, green hydrogen, right? So when you depend on the blue hydrogen or gray hydrogen, and there is a huge difference in terms of CO2 emissions what we are giving to the environment. So that difference also needs to be calculated as a part of fuel efficiency. And now today in India, the recent development I just want to give as a gist to you. We are also seriously working on this one, how to reduce the CO2 emissions. How to reduce the CO2 emissions, not only from conventional, it is for the all vehicle categories. We do not have any methodology today in India. We don't have any methodology for the real life fuel efficiency calculations, which are going to give the realistic measurement. So that is the basic bottleneck or gap which is there in India. But is it possible to test it? Is there any solution to test? There is no methodology available for India, especially. And Europe has developed their own methodology. They took 12 years to develop. Japan has developed their own methodology. They took sufficient time to develop. But when it comes to in India, there is no methodology. But that methodology, what we are going to do it, is also should be agreed by the all OEMs. Because my work, what I am doing here or what I work, is that it should be acceptable. I cannot do the academic type of work. That should be acceptable to the many stakeholders. Then only my work will have some validity or consideration. In this case, if you take a commercial vehicle of greater than 3.5 ton up to 55 ton vehicles, can I develop or can I test that vehicle on the road? It is quite impossible. So that's why there is an approach is called simulation approach. And this simulation approach is giving the many benefits. Like for example, building proto vehicle of for physical testing can be avoided because it's very expensive. It's a cost effective, quickly provide the solution, and you can do the parameter sensitivity analysis. Parameters in the sense there are n number of parameters. I will mention few names over here. Tire, vehicle geometrical dimensions, frontal area, gearbox efficiencies, differential efficiencies, engine and its subcomponents efficiencies. All those parameters we can study and understand which component has having potential to improve the fuel efficiency. This is a kind of a new program or new kind of approach what industry is following when it comes to the net zero policies, net zero emissions. Yeah, there are many technologies, many options, many open areas available. But when it comes to the net zero policy, everybody is working across the world, everybody is working. This will help us to not only improving the fuel efficiency, it will also help to extend the range of the EV vehicles, extend the range of H2 ICE vehicle, extend the range of fuel cell electric vehicles. Okay. Now we'll see the worldwide scenario very briefly and quickly. You can see here whatever the fuel we are consuming today in India, this consumption is about 73.6% is by transportation sector. About 26.4% is by other industries. Okay, here also you can see the distribution. This distribution. Then you can see this particular area. This is very interesting part, about 41%. Out of 73.6, 41% is only by buses and HCV category, and it is coming around 60 to 66 per 60% of this one. So now focus, it is already taken care by the many policy holders and many other regulations are already taken care by this segment, but this segment is untouched today. It was touched, but not fully touched. So now we are working in this area. You can see in India, when we see the present and future, we are currently depending on one speed, that is constant speed fuel consumption. So one speed optimization is always easy than mapping the fuel efficient system across the entire operating zone. So which is not being used by anyone in India, anyone in the world. We are only using, now we are trying to discard this one. Future is that developing a new approach based on the drive cycle of category of vehicles greater than 3.5 ton. So there is a new approach what we are developing. It is in work is in progress. I may not be able to disclose many of the things, but yes, work is in progress and it's good activity supported by government as well as other industry partners. If we see across the world, everybody adopted this approach except India. So India also hopefully in couple of years to 4 years time span, it will be adopted most probably. We are trying for that. What are the key benefits? The benefit is that we can estimate the how much CO2 emissions producing by this exactly, and also support the global warming policies as well as Paris Agreement policies. And the procedure is that it will help to reduce CO2 emissions by setting up the targets based on the actual predictions of any vehicle category. So these are the conditions. We can also achieve the national level. It will also help to the manufacturers, and it will also help customer to select his interested vehicle or his interested model. So this is one small example what we have tried out, and this is validated within 3%, which is acceptable. The work is in progress. Okay. Before going to this type of activity, we need to analyze the how much energy is distributed. You can see, hopefully you will be able to see how much energy is losing at engine level, how much energy loss at wheel level, drag, gearbox, differential, and other areas. Once we can understand these locations, it will be easy for us to identify. So here, this particular concept or this particular approach, we are not limiting to only commercial diesel engines or gasoline engines. This concept is applicable across the any vehicle category. Let it be EV, let it be fuel cell or hydrogen. So it's going to be applicable. Concept is remains same. Only we have to do the application research. So you can see that overview I'm just giving over here. Any vehicle will have these different types of losses. 100% energy when we are giving, the tank to wheel efficiency, it's going 100 is going to come down by 15 to 16%, or maybe sometimes up to 20 also. In electrical vehicles, it may go up to 23 to 25%. That means almost 75 to 85% energy loss is in these areas. If we can try to improve 1% in all these zones, that will be a great benefit to the society. At the same time, end user will get benefited. So this is the like kind of a program what we are doing, and it's a new approach and new program to help and to find out the different ways to improve the fuel efficiency by studying the different vehicles, different parts, different subsystems losses and its efficiency improvement. So in this process, we can do approach like this. Maybe if why I have given this presentation, there is a interest and logic behind that. Since being a faculty members you are all, so this kind of approach may be helpful to you to do some more research in this area. That is the main thought process to select this particular topic. It may be very short and small topic, but interesting topic. You can see the different vehicles, which vehicle is giving better efficiency, which vehicle is having more potential. We can do this benchmark. And this is important task in this. We have to study based on the real world usage pattern, that is RWP. So this real world usage pattern need to be generated and not required to generate for every vehicle, but depending on application need to be generated. Now we are developing this particular map for entire vehicles in India. The second is that aerodynamics testing and simulation. The testing of the aerodynamics, you can see here, you have to build the vehicle, and that build vehicle to be tested in the field and measure the aerodynamics drag. It's a very expensive process and need to be established a simulation approach. And again, aggregates or auxiliaries efficiencies. This data will be useful to identify the percentage distribution of the energy losses. This can be used for any vehicle, as I said, and bring it to the all this physical testing to the desktop level assessment. But here, one thing we should remember or need to be understood, the quality of the data, what we are going to acquire, that will only make you to make us differently in achieving the results here. Suppose if I get 12% gap correlation, not acceptable. That gap should be at least less than 5%. And that gap cannot be achieved by manipulation. So that gap has to be achieved on its own. But when it is possible only if we can give due attention during this particular activities, all these activities. So this is the kind of challenge here, definitely. Once we do this one, we can get this type of efficiency distribution. Now, in this particular program, this is a small example. I just want to show it here. If you can see here, this is 15 to 18%, and this is 12 to 14%. This is about 58 to 61%. If I improve anything over here, this entire improvement will goes to here. This is what we need on higher side. So this is how we generally do the fuel efficiency improvement programs on vehicle energy audit or for different vehicle categories. These are all these vehicles possible to carry out, and we are working on this very aggressively with entire system. We have generated a system. We have some consortium formed for this, along with OEMs, ministry, and so many other stakeholders. So with this, I will stop this presentation. I will go to the another presentation here. Any questions till this point? Please let me know if you have any questions so that I will try to answer. Otherwise, I will switch over the presentation to another new technology concepts where we will get the good fuel efficiency improvements.
Dear participant, do you have any questions?
Okay, you can park your questions.
You can type your questions in the chat box.
Yes. So I will start from this slide here. There is some change in the number years. Okay, small change in the years. So otherwise, objectives are more or less same. Okay. You can see here, particularly focusing on the CO2 emissions and GH. Yeah, years are going to change, but obviously we have to reduce this one. This is possible only through fuel efficiency. So one program I am going to show today that what way we can improve the fuel efficiency at engine level. Okay, that one program I want to show. See, we have a lot of demands. You can see here all these demands, and we have some of the requirements, and we have another limitations of this one. Demands are legislative cycles I have to meet. Extreme operating conditions, engine will run or vehicle will run. Technology options, various the cost of the total engine or this one will be high, and I need low maintenance, ease of service. These are all demands from the various sources. Because considering all these demands, I have to meet emissions compliance, efficiency improvement, and my system should be accommodatable for the different fuels. You know that flex fuel concept is in discussions today. You might be aware, flex fuel concept. Okay, and dual fuel concept is already there, but people are going for the flex fuel concept. But for all these things, there is a limitation in the sense time, manpower, resources, cost. So any program when we do, we have to see from all these angles. One is legislative requirements, second one is compliance, third one is what I have to develop. So we struggle between all these parameters before going to the any new activity. So this is the one activity we have taken up. To improve that, there are three parameters. One is reduce the weight. When you reduce the weight, now you know Bharat NCAP is there, the star rating from the structural point of view. Bharat NCAP. The full form is that Bharat New Car Program. Second option is increase the power from the same engine and low emissions fuel consumption. So in this, there are different losses. Most of the professors might be aware about what are the different losses. So these losses, we try to tap it in this program. So this one, how many of you believe that diesel engines are going to be there for long time? Do you think that today, in present scenario, EVs are going to replace diesel engines? Any idea? Just a question to you all. Any idea or any guess on that? As far as I am concerned, okay, my experience or my analysis point of view, diesel engines are not going to die. It will be there, at least the today who are all there in this particular session, till our last breath, diesel engines, definitely it will be there. That is the first note. The second is that to replace diesel engines with battery is going to take very long time because of its own limitations for this particular category. Third point is that if we can replace, or if you are planning to replace diesel engines with fuel cell EV, again there is a technology limitation, technology readiness, technology maturity, and at the end, overall cost of the system. While we are selecting all these parameters, emissions at the source, whether the emissions at the source same, high, low, this also play a role. So considering many other parameters, let us focus on the diesel today. This I will skip it for the time being. We can also see here that there is a balance between the global emissions and local emissions. As far as present regulatory point of view, this is our main concern. But when we see the future generation sustainability point of view, this is the concern and worry. That's why Paris Agreement 2016 happened and 194 countries signed on that. So this now the focus is shifting because this is already taken care by many technologies. And this is the one which is not completely attended or attempted by the governments or the research bodies or advanced countries like USA also. Today, I think you have seen news, they want to come out of the Paris also. Okay, that we will not discuss. So we tried one of the concept, low temperature combustion concept here. And we have taken one engine and modified that engine and see the possibilities to improve the fuel efficiency by reducing the emissions. And when if you can see that low temperature combustion concept, this is applicable to any type of engine. Nothing related to the only diesel. This concept is applicable to any engine. This concept is applicable to alternative fuels like CNG. H2 is also, obviously it is useful. So there is kind of a balance between the SI engine, CI engine, low temperature combustion or homogeneous combustion. So this balance will help us to reduce the emissions at source and also fuel efficiency improvement. I'm not going into the details because of the time constraint. Okay, the concept when we see here, any engine if you can run, you cannot avoid the formation of the soot and also NOx. If you try to reduce soot, then NOx will increase. If you try to reduce the NOx, soot zone will increase. And always engine will travel like this particular orange color line. It will travel, its path is through soot formation as well as NOx formation. So in new technology, what we tried couple of 3 years before, we try to run the engine in this path, avoid the formation of both soot and NOx, and then improve the fuel efficiency. So there is good amount of work we have done, and that work also I will show it here. Okay, the concept here is the flame propagation and also start of combustion, duration of the injection, everything is to be tuned. As I said, diesel engines are not going to die, and we are working extensively on diesel engines, and we are implementing this concept. Okay, means as a mechanical engineer or as a technical person, I cannot leave what I am doing, but at the same time, I should add what is required for the future. This is how we are working here, and this helped us in many programs and many projects. So we got very low NOx, we got better fuel efficiency, we got cost-effective solution also. This is the practically implemented program I'm talking here. So this difference, I will not go through this one. I will go to the results quickly. Yes. Yes, here I will go through this one. This is generally our conventional operating zone of the diesel engine, and we generally operate, this is the operating zone, or when we run the engine or vehicle on road, this is these are the points where engine will run. So this entire points matrix converted into the few points, approximately 14 points, by using weighted average method, 14 points, and these 14 points we optimized first. After optimization, we identified the zone where we can run the engine with full low temperature combustion concept. Then thereafter, we have minimized the LTC concept and slowly moved towards the conventional DI. That means partially benefit we have taken by using the new technology. While we are moving from zero load to the full load, we have this transmission is happening slowly, gradually. So this is how we have mapped the entire engine program first. Then you can see the results here. How beauty you can see. Conventional is 6.71 NOx. A new concept is almost 1/3. and particulates also almost 50%. Okay, this is how the new concepts are going to help us. But of course, facilities are also important. Manpower is also important. Like you can see here, fuel efficiency, 8% improvement we got it only from engine. 8% improvement. So you can see here that entire operating zone of the vehicle. When vehicle is running in the field, that how the engine is operating, and each operating point, what is the BSFC? This is the cumulative BSFC measured at different points, and this cumulative BSFC converted into the cycle BSFC. So this is one example I just brought to your notice to say that there are many open areas, there are many new areas which are available to improve the fuel efficiency point of view. Now I'm switching to the another presentation where you can see the fuel efficiency improvement with different parameters, or you can say that parameter sensitivity on fuel efficiency. Give me 1 minute time. I will switch over to this one. Because of confidentiality, I will not be able to show completely, but I just want to give some kind of energy or some kind of inputs from research point of view. Just a couple of slides I want to show here. You can see here one small program what we are doing here. This is a battery. Okay. So when we see the battery, it's like a motor. When we see the motor will have a typical characteristic. What is the typical characteristic? So at low speed,
Excuse me, sir.
very low
Your
speed.
voice is not audible.
Is it? Now, am I audible now?
Yes, sir. Yes, sir.
Yes.
Your
Okay.
voice is audible.
Audible. Okay. It's like a typical characteristic motor will have. Initially, it will have good torque, but that speed is very low. But as the speed improves, then the torque suddenly drops in the motor. And also efficiency map, if you can see, it's different efficiency at different speeds. Then where to run the vehicle? What should be the zone so that we can get the maximum efficiency or maximum well to wheel or tank to wheel efficiency, battery to wheel, here in this case battery to wheel. So now here we can study given motor characteristic curve, this is the characteristic curve, where the points are mapping, whether it is in good efficiency zone, whether it is in the bad efficiency zone. So this will help us to give a feedback, or this will help us to understand what is exactly happening in the motor. If we can get this particular data accurately, I don't think it is possible from the academic point of view, getting a data, but if we can tie up with some good university, either in China or maybe outside, it is possible to study more in detail. And this particular concept will help us to understand the specific energy consumption. What is specific energy consumption means? How much kilowatt hour is consuming for every kilometer, so that this will help us to improve. This has to be improved. Now, this is the value of current vehicle on road. This is the value we have targeted. This is the value we improved. Okay. Just I'm giving a gist because I cannot go much details of this particular program because of confidentiality point of view. So there is lot of scope, fuel efficiency improvement point of view. When we say fuel efficiency improvement, I'm not limiting to only IC engines. I'm not limiting to only vehicles. I'm expanding this requirement across the platforms, starting from the IC to fuel cell vehicles. Okay, this is just an overall overview of my presentation. So I want to conclude over here. Hope I have given some bullet points of future requirement and bullet points of what is happening in the current scenario across the globe to control the CO2 emissions and what government is thinking. Okay, what I am saying is that I am concluding my presentation over here. Okay, so before while concluding the presentation, I am just giving a small gist about the presentation. My main objective of our idea of today's presentation is that what exactly world is looking for, that not only technology, they are also looking for the converting the existing technology to a efficient technology to reduce the CO2 emissions. So in this area, what we are working and how we are working and what are the areas we are touching for this as a part of net zero policy 2070. We are working for the net zero 2070 part. And in this many programs, some of the programs I will not be able to disclose, but hint I have given so that some of you can pick up and we can work together also if there is a good activity, a good scope to work together.